Hello everyone.
Hello.
Hi everyone.
Hi Rohi. Hi Mugdha. Can you hear me?
Yeah, Sudha, you're audible.
Okay. I hope you can see my screen as well, right?
Yeah.
Give me 2 minutes, then we can give it a start.
Okay.
Okay, I think we can make a start now. So I just ran this notebook until what we have done until yesterday. Let's take a quick pause and see if there are any questions from what we did yesterday, because we have just started doing it. Maybe you don't have one, but if you have any questions, please do let me know. No, I hope. Uh, it seems there are no questions, right? Okay. Then let's try and continue. So what we are doing over here is we saw that via scalar only we have a feature by means of which we got the housing data set, right? We got the data set from a function, and from there we are able to extract features and columns separately. At later stage we'll have to join this, but let's not deep dive in there. Right now, let's look into this last command that we have run. Let's try to analyze what is happening here, and we are going to use visual approach. So let's try to look at what is going on over here. So the first is CRIM, crime rates. I believe this is what it meant. Let me just do one thing. Let me just open my notepad and let me try to, yeah, per capita crime rate by town. Yeah, that's what CRIM is. Okay, so per capita crime rate by town, what it is showing here is the mean is 3.61. Okay, mean is 3.61. 8.6 is the standard deviation. We'll not get much info only by combining these two, so we need to look at minimum and maximum. So if you see 75% of my data falls by mean. My median is this. Okay, median is 50%. So median is less than mean. Okay, can anybody tell me how the skewness is going to look? Will this be a left skewed or will this be right skewed? Any idea?
I
Any
think
thought?
it will be right skewed.
Okay, okay. Let's validate that. So what we are going to do, import matplotlib dot pyplot as plt. Before even we do that, let's go back to our previous cell and we are going to say new cell and no, not here, here, yes. So we are going to add a new cell and we are going to say, let's visualize each of the variables. So there is a very easy way in which I can do a pair plotting, but I don't want to do a pair plot. It's simply going to complicate things. Let me just go ahead individually. I've just imported the library. Let's wait for 1 minute. And then it will be easier for me to see whether or what kind of distribution I have. There is one easy way in Cbond, which is to use the disk plot. Maybe I'm going to use that. Import Cbond as SNS. So let me just import both the libraries. In the meanwhile, what I'm going to do, plt.hist. I believe histogram is one available option there. So features, and then in brackets, I'm going to say CRIM. Let's see what is the outcome. Dot show. So this is going to give me the histogram. As you can see clearly, it is it left skewed or right skewed? Where is the skewness? Is it on the left side or on the right side? It is on the right side, right? So the skewness is over here. Let's just try to confirm this from this plot as well. Should be able to plot the distribution of the crime rates, and we can clearly see how the graph looks like, right? So it is right skewed, right? It is right skewed. So median being less than median, this value being less than mean, it is quite less than mean. So it's quite a big kind of a difference, right? So a very big difference between median and mean, where median is actually far lesser than mean. It means it is a right skewed kind of a distribution. So this is actually a problem. The reason why I'm going through each and every of these things, right, is because I'm going to tell you things which we did not cover earlier. So that's the objective. When we do practical things, we look into more aspects of how to do it in the real world. So if this is the scenario, right, so if I have any data set where I have this kind of a property, let's look at others as well. And to do that, I'm just going to use a very quick formula and something which we have seen earlier. I have this variable, right, feature columns. I'm going to use this, and I'm going to say for each column in feature underscore columns. I think feature underscore columns is the name. Let me yeah, feature underscore columns. For each column in feature underscore columns, I just want to do this. So I'm going to take this and put this code over here. Okay, and then I'm going to say print, and then I'm going to say this kind of a line. I'm going, oh no, why? I don't need to do that, right? I can just say print 2 times. I can just say blank prints, and this should work. So what I'm going to do, instead of this feature over here, I'm going to say each column. Okay, this should work. This is not a very efficient way, but yes, this will work. This will take some time because distribution plot takes time. Okay, so as you can see, it has only plotted 2 variables as of now, but this is a good way. This is a very easy way, to plot each and every variable and try to see the distribution. Okay, the distribution will be clear, and we will be able to understand what the overall distribution of each and every variable is. The reason why I'm saying this is because we know what is the assumption of linear regression. One of the assumptions of linear regression, the features may or may not be linearly distributed. Okay, and this is one of the assumptions of linear regression. If remember, can anyone else tell me what all are the other assumptions? If anyone remembers the notes that we also saw earlier. Anyone? A very first thing is we have some kind of linear relationship, right? That's obvious. We have a linear relationship between features and the targets. So we are going to find that if there is really a linear relationship or not. And then basis that only we are going to select our features. But the rest are homoscedasticity, right? One of the most important features, homoscedasticity, and the no multicollinearity, right? There shouldn't be any multicollinearity. The features should not be interdependent on each other in the sense that they are not affecting one another. So that's another very important kind of a property, right? The other property, if you remember, we really do not need each and every feature variable to be normally distributed. Okay, if it is normally distributed, that's a good news for us, because if it is not normally distributed, can I consider these points as outliers? Maybe I can consider these points as outliers. You know why? Because this is the average crime rate. You see, the average crime rate in many of the areas is concentrated over here. Obviously, I have some areas where the crime rate is really, really high. Okay, obviously, in these places, my price will be very less because people will not prefer buying house in an area which has high crime rate, right? So price will go down, but then in this cases the price will go high, which means there will be a lot of variables, right? There will be a lot of data points which is dragging my output towards a higher value. Are you getting my point? So if in this range, what is happening is, because the crime rate is very high, although there are lesser instances as compared to others, the instances are lesser. Okay, please do remember why the numbers are like this. This is a PDF. This is a probability distribution function. So that's why I see numbers in the range of 0 to 1. They'll not go beyond 0 to 1. Okay, so overall, if you look at the plot here, the plot over here, it also looks the same, right? I'm just trying to put the plot right inside the diagram, so you can see there are lesser quantities over here. And this is not a PDF. This is just a histogram. Okay, this is a histogram. This is HIST, histogram. In case of histogram, I can clearly see what is the distribution. There are many cities where, or many places where the crime rate is really low. There are certain places where it is really, really high. So I may have outliers. So do I need to treat that is a very important question, right? So these are kind of questions which are getting answered. If you look at the data, these are kind of things which will get answered. Okay, so these are things that we have to remember, or even better, what I do or what I prefer doing is that I write them down. Okay, I write them down. So let's just try to write them down over here. Okay, let's just try to write them down in some notepad, and then we will finally put it into our main let's say notebook. So we'll take a notepad here. Let's take a notepad. Let's take a notepad. So this is finding notes, right? So 290922020. I'm just giving the date, and here crim, okay, variable has is right skewed, right, and contains outliers. Okay, so what I can say, there are places in Boston which have comparatively 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 far higher crime rate than others, but almost always, or 75% of the cases, are where we have lower or acceptable amounts of crime. How did I say this 75% thing? How did I say that? Because if you look at the summary once more, let's go back to our notebook again. If you look at the summary, you will come to know. If you scroll up, let me just scroll up. You see 75% value is almost same as the average value, right? So that's why I can say this is the case. The same thing is apply for Zn. Okay, what is Zn? Let's try to look what is Zn. Zn is the proportion of residual or residential land zoned for lots over 25,000 square feet. A bit difficult to understand at the first place, but the main idea over here is as simple as how much is the proportion of land where we have the apartments or where we have homes, right? So if I again come back to the diagram, let's just go through each and every diagram and we'll understand what is happening. So Zn is also a right skewed kind of a data. Okay, Indus is a multinodal data. Okay, multimodal, I'm sorry, it's a multimodal data, near to normal, but it's not really normal. This is multimodal. Okay, so I can write Zm, Zn, or Zm. Yeah, Zn. Okay, Zn has similar characteristics as as CRIM. Okay, CRIM. That is what I can say from this, that the density of overall houses in per 20,000 square feet area, right? A 20K square feet areas of land is quite less, right? Is it quite less, or it quite more? Let's go back to the definition. What is this saying? Zn is proportion of residential land zoned for lots over 25,000 square feet. Proportion of residential land. So proportion of residential land, if it is having more lower values, then the proportion is less, right? So the proportion is lesser, and higher proportion, the occurrence of higher proportions is less than the occurrence of lower proportions. Since I can say the density of overall houses in per 20,000 square feet areas of land is quite less overall in Boston. Hence, we may say that it is not a place where we will see overcrowded setup of homes, right? But it is not really a uniform kind of a distribution. But this is a good, let's say, distribution. This is a good distribution when it comes to Indus. What is INDUS? INDUS is the proportion of non-retail business. Proportion of non-retail business acres per town. Okay, Indus is multimodal, or I can say bimodal. Okay, bimodal. That is, uh, we see different varieties of cases in the proportion of. I'll just take a copy paste from here. That will become easy, right? In the proportion, I can say, in the proportion of non-retail business acres per town. Okay, what does this mean? If we have this kind of a data in place, then it simply means, let me just do one thing. Let me do one thing very quickly. Let me just do one thing very quickly. This will make my life easier. This will make my life easier. I'll just take this and put it over here. Yeah, and this makes my life easy. These are the variables, and this is what I'm trying to do. Now I can only concentrate on the diagrams. So we have looked into CRM, we looked into ZN. The next is Indus. Okay, Indus is what? Indus is proportion of non-retail business acres per town. This is bimodal. It means there are two such cases. Okay, there are two such possible areas where the proportion of non-retail businesses are higher. Okay, that gives you an idea what kind of people, okay, what background of people will be more interested, okay, to stay in this area, right? Then I have CHAS. CHAS, I believe, is a kind of a categorical column, okay, because it's giving me data like this. Let's see what is CHAS. Did it come in the describe? Yes, it came in the describe, but it's obviously a categorical column. How did I get that? The minimum is 0, the maximum is 1. So CHAS is either 0 or 1. It's kind of a categorical column. You see, there is no distribution it could plot. So that's the warning that it is giving here as well. Default bandwidth for the data is 0. So it is not able to do any density estimation. So it is using a technique called kernel density estimation, and it's not able to plot that smooth graph over here, right? Because there is no distribution. It's like you have a lot of entities on the point 0, and then you have some entities on the point 1. This kind of a data, this kind of a feature, I can also say it is not really a balanced data. I can say it is an imbalanced data. Imbalanced. It is really imbalanced because I have a lot of entries for 0 and I have some entries for 1. Okay. Now let's try to look what this was. Let's clear the diagrams, and I okay, Charles River dummy variable 1 if tracked bounds river, 0 otherwise. Okay, so there is much less area that has the tract bounding the river. Okay, there is much less area in just variable or feature. We see imbalance in the sense that we have more cases where the tract does not bound the river as opposed to the otherwise cases, right? So it means these houses, right, the area is mostly concentrated of houses which are not near the city or near the shoreline. I'm sorry, no, not the city. It itself is a city, right? So it's not near the shoreline. So that's a good idea. This can give you some idea. Example given, people who are interested in staying near areas where it's kind of a beach or a beach is available. People who are really interested in staying in that kind of an area will not choose Boston, right? Then I have Knox. This is somewhat, this is quite close to being a normal distribution, not like RM. RM is beautiful. RM is really normal, but Knox is kind of right skewed, I can say. It's kind of right skewed. It has a skewness. It has a tail on the right side, kind of right skewed. But what is Knox? Knox is nitric oxide concentration, parts per 10 million. Okay, so Knox feature is is right skewed to a small extent, which signifies that overall nitric NiOx, I'll say nitric oxide concentration in Boston. Okay, parts per 10 million. I'll skip that part. So parts per 10 million. Okay, parts per 10 million is on an average in acceptable limits, or so we can assume. Okay, we don't know the actual technical value, right? We can't say that majority of the values are below this value 0.6 or 0.7, that's why it is good. Maybe here we'll need some kind of domain knowledge. We'll need to bring some domain expert who understands what is the acceptable limit of nitric oxide concentration in air. Okay, then only we can answer this question, or otherwise we can't. But okay, we have at least got some finding, right? So that's good. Then the next is RM. RM is beautiful. I really like this variable. RM is what? Average number of rooms per dwelling. RM is a properly normally distributed column or feature, which means overall distribution of average number of rooms per dwelling is very well thought of. Now this is a confusing statement. I'll tell you why. Because if we have normally distributed data, right? So in this case, we are seeing that the number of rooms, the average number of rooms per dwelling is like normally distributed. So we have on an average, how much is the average? Approximately 6.1 or 6.2. So average 6 rooms are there per dwelling. Okay, is this going to affect the price? Might be. So we have to take this into consideration. This is going to affect the price. Similar to that CRIM variable, right? CRIM variable is going to affect the price. NOx is going to affect the price. How am I coming to such kind of an intuition? I'm coming to such kind of an intuition using plain and simple logic. If nitric oxide is less in the air, or it's less than the average in the air in most parts of the city, then it means the pollution level is really under control. If I understand nitrogen oxide properly, if my assumption or my understanding of nitric oxide's concentration in the air is correct, then more of nitric oxide means more of, let's say, pollution, which means if I have lesser than average concentration in any area in Boston, it means it is quite clean, right? If the city is clean, there is a probability more people will try to buy homes over there, and hence obviously it's kind of a demand supply game, right? So the demand will increase, right? The demand will increase, hence the supply is also going to increase, right? Right. Now let's look at age. Okay, so I see there is a small problem over here, but that's only my intuition. That is my hypothesis. It may or may not be true. It really depends on what kind of people go there to stay. So I'm going to write, in case of age is a feature which is left skewed. Okay, that is I have I have more number of, okay, or more proportion of owner occupied, yes, units built prior to 1940, which means that is I have more old houses. So these houses will look old as well. If they are old, I hope they are really maintained well. But then they are like the old stone like houses, right? I mean, they might look old, they might be a little old. I don't know when this data was taken, maybe it's old as well. So the houses might look a little bit old. So uh, which kind of people will prefer that? Maybe there is a specific group of people only who will prefer having, or to live or buy a house in an area which is really old, right? So it has some kind of cultural attraction towards it. But then if people are really metropolitan, they may not really accept it. I mean, I don't know, they might accept it, I don't know. Maybe they will accept, maybe they will not accept, I don't know. But this is confusing. I mean, this may lead to some variations in the price. Let's see. Okay, let's see. The next is DIS. What is DIS? DIS is weighted distance to 5 Boston employment centers. Okay, this is DIS. Let me take a copy. So DIS feature, as I could see, is right skewed, which means there is more concentration on the lower values. Okay, is right skewed. Okay, that is the weighted distances to 5 Boston employment center is average on the smaller side. or average word is really wrong over here. Overall, yeah, overall on the smaller side, which means that houses will are more likely to be closer to the employment centers, right? Which means people have more option, right? People will have more option to look for jobs. It means people who are living in these kind of areas, maybe I'm going to use a pen. So if I bought an apartment which falls into this kind of a territory as opposed to this kind of a territory, maybe I don't know, it's just an intuition. We will do more visualizations to find things out. Maybe the price over here is going to be higher, right? Maybe the price is going to be higher over here as compared to here maybe the price is going to be low, right? Because it is a bit distant from the from the places from where we can get or we can apply for jobs. So maybe it is going to affect. But then there is another side of it. I mean, if we already have old houses, then people, and we have good, let's say, already the price is quite high in that area, then maybe people who are buying apartments there or houses there, they already have that much of budget. Maybe they're already retired. I don't know. Are they really going to look for jobs? I don't know, right? I don't know, I can only assume these things, but let's see. I mean, the moment we do pair plotting, it's going to be more easier. But before doing pair plotting, we have to join. Please do remember, we have one data frame which contains the features. That's what we are looking at. We have to create another data frame, which we have not done yet. We have to create another data frame which contains the target, and then we have to join these two. Then only our final data frame will be created, and then only we can start working on it. So before that, let's look into RAD. RAD again is bimodal, but this mode, the lower mode is actually higher than the higher mode. What does this mean? What is RAD? Let's see the definition. Let's see the definition of RAD. RAD is index of accessibility to radial highways. So RAD is bimodal, which means index of accessibility to radial highways is actually more. Okay, so the index being less is more. So the value of that index being having a lesser value is more, which means I can write a RAD feature is bimodal, and lesser valued entities have more concentration, or let's say have higher mode than, or have more concentration is a good word, more concentration, right? That is, it is, it is quite possible that people buying houses in such areas will have more quick access, right? Will have more quick access to the highways. Okay, this might affect price, right? Houses closer to highways might affect price. I don't know. These are just my assumptions. Let's see, right? We'll find out. Again, the same thing happens with tax. To see the distribution over here, this is explaining most of the variability as opposed to this. I mean, this part is really small. Although there obviously this data will be bimodal because it has no data in between. That's why it is becoming bimodal. I hope you all got the concept here. So uh, here in this case, what is happening is, again, it is bimodal. The first mode is greater than the second. The first spike is greater than or higher than the second spike, right? Which is a good indication. Many of them fall in the lower brackets. What does tax mean? Let's look at this. Tax is full value property tax rate. So tax tax feature is bimodal, okay, and lesser valued entities have more correlation. That is there are more properties, I can say properties with less full value tax rate per USD 1000, USD 10,000, USD 10,000 as otherwise. Okay, this is a good news. This might really affect. I mean, if the property tax is less, then people might get inclined towards this. But then there is a problem here as well. So this is causing a bias. There will be some areas where the taxes are low, some areas where the taxes are high. People will be more biased towards this area, right? These are kind of things that you have to look out for. They're contains biases in the data. There will be problems, but we don't know that yet. We are just assuming it. The next is PT ratio. Okay, PT ratio seems to be right skewed. No, I'm sorry, it is left skewed. PT ratio is left skewed. PT ratio feature is left skewed. Okay. Then what is PT ratio? PT ratio is pupil teacher ratio by town. Right? It means that is overall the pupil teacher ratio in the towns is more, right? Throughout the city it is more. You see, there is a more values or higher values are of more concentration over here. It means I'll have schools where I'll have more uh, uh, I will say uh, I'll have more students to I'll have more teachers to students ratio, which means that if I put my kid there, I'm just trying to visualize, then there is a very high probability she'll actually get a lot of attention in school, rather than, let's say there is a class with 50 students and only one teacher, and how much will that teacher do, right? End of the day, the teacher is also a human being. So what if the pupil to teacher ratio is really high, it's really good, right? Then that's good, if I've understood this correctly. So pupil teacher ratio by town, pupil teacher ratio is higher, pupil teacher ratio is higher. Is my understanding correct? Let's think about this. uh, let's do some Google search. Let's do some Google search. Why to take a risk? Pupil teacher ratio is high. What does this mean? Okay, I'm just trying to show you the entire workflow, because this is something that you will need to do yourself. This is something whenever you are working in a project, right? Whenever you are working in a project, you need to do this. Yes, I thought so. I was wrong. High student teacher ratio is often cited for criticizing proportionately unfunded schools or school systems. Let me take this statement. I really like the way they have phrased it. So basically, this is the ulta. So is more. That is you can simply paste. We have a not so good situation, also often cited for criticizing proportionately underfunded schools or school systems. Okay, also a situation which is often cited for criticizing. So there might be problems. My initial assumption was wrong. This is where domain knowledge is really going to be useful. So PT ratio being high means you have one teacher for, let's say, 50 students, right? That might be the case. That is why that is what is being said over here. High student teacher ratio, right? Maybe that's going to impact the housing, or let's say uh, the prices of the house. I don't know. Let's see. The next is B. This is a very bad kind of data. It's almost similar to crime. Crime was on the other side. B is on this side. What is B? BK is the proportion of blacks by town. So this is 1000 blacks minus 0.63 square, where BK is the proportion of blacks by town. What does this mean? BK is the proportion of blacks by town. Let's say the proportion is 1. Then what is this value? If the proportion is 1, if the proportion is higher, then this value becomes higher. The square also becomes higher. Then this overall value becomes higher, right? So if BK is higher, right, then the difference between BK minus 0.63 and then a square, okay, then a square. This is not a square root, this is a square. So if this value is high, obviously its square is also going to get high. I multiply it by 1000, that's also higher, right? So higher B means higher concentration of blacks by town. Okay, so I can say, although I'm not trying to discriminate anybody by their color, B feature is highly left skewed, left skewed. That is, will people like the fact that in Boston, overall, we have more areas with very strong concentration of black, right? Maybe people who are not really as educated as we are, or maybe people who don't really like blacks, they are, let's say, people who do discrimination. We are not in that grade, but there will be people, right, who will be doing, let's say, discrimination, but will they be more interested? I don't think so. So that's one way of looking into it. Will people like the fact that, or in other words, I can say, will more black people, okay, prefer staying here, okay, in this area, because they have their own concentration more, so they'll feel a bit more secured, a bit more safe. That's human tendency, right? I mean, there is nothing wrong. So then I have L stat. It is near to normal distribution. Near to normal. This is my target variable. This is my target variable. Okay, this is my target. Let me just clearly segregate my target. Let me go control home, and these are my features. Okay, so features are this. I've done covering the features. L stat is what? Percentage lower status of the population. Percentage lower status. So percentage lower status is like, I mean, there's a good concentration. I mean, I'll not say this is really right skewed, and this is almost close to a normal distribution, right? I mean, if I try to draw a normal distribution, it will look something like this. It's almost close, right? So it's tending to normal. So this is good. I'm not saying it's really bad. It's really not bad, which means I can say L stat, right? L stat was the name of the column. L stat, yes. L stat feature is very close to being a normal distribution, or I can say very close to having, not being, very close to having a normal distribution. This implies overall similar paying uh, people reside in the areas, right? So almost all of the people who are staying in this entire area may have a very correlated kind of, let's say, salary, or is it? So I don't know. These are kind of questions that I can solve. So maybe I can take this now. I can take this entire thing that I have written over here, and I'm going to put it over here. So I'm going to say findings. I'm not going to put any findings is this. Okay, so these are my findings. I've clearly written my findings over here. So I think that's a good overview that we have got of the data. But then I could clearly see there can be, close relations between one variable and another variable. Right? There might be. I mean, we just have to get rid of that. We have to find that out if there is any interrelationship between these features. Okay, let's look into that. Right, let's try to clarify if there is any interrelationships. How am I going to do that? I know I can plot a heat map, right? So I can say, let's now look at correlation, okay, within the features. This concept is otherwise known as, can anybody remind me what this component is? Features are not really independent, they are correlated with each other. What is this phenomenon known as? Anyone? Anyone?
Bhumi, maybe I know this, but
Yeah.
let others can answer.
No, no, go ahead. No problem. Go ahead.
So, so you mean what is correlation, right? Correlation between features.
Yeah.
Okay, so it is the dependency of, let's say, the independent variables
Hmm.
among among each other.
Okay. Is there any name you can give it?
With name.
Yeah. Is there any name to this phenomenon that if we see that features are correlated highly with each other, what do we call that situation?
It's we call it multicollinearity.
Yes, very good. Multicollinearity. Right? Multicollinearity is a problem. We should not have multicollinearity. Right? That's the reason why I asked this question. The basic assumption of linear regression, one of the assumptions or one of the main features is that we should not have multicollinearity. We should be removing it. Now, how do I find out? So I need to find out that I need to use that function, right? Dot .corr, if you remember. So there is a dot .corr function I can use with the data frame. So I'm going to say features dot .corr, and it should be giving me the correlation. But now I do have a lot of values. It's really very difficult to look at this. Okay, these two variables are highly correlated. I can find out this is okay. I'm not saying it's very high, right? But there is a good correlation in here. This is very difficult to find, right? Visually, this will become very easy. So what I do a heat map, sns dot heat map, and then I pass this correlation value over here, and then I do plt dot show, and I get the heat map, and it should show me what's the kind of heat map of correlation between variables. So you see, age and DIS have a very high correlation, very high negative correlation. Anything going towards high, towards lighter colors is positive correlation. Let me do one thing. Can we do this? PLT dot figure, and I'm going to say fig size is equal to I don't know 11 comma 11. Let's see if this takes. Yep. So I can see this value, crime and RAD. RAD. Okay, what is RAD? RAD is what? RAD is what? RAD is this index of accessibility to radial highways. This is highly positively correlated. This is quite well positively correlated. You see the values is quite, no, I mean, this color is even more higher. So why not take this? Indus is highly correlated with tax. Indus, what is Indus? Proportion of non-retail business acres per town. Indus is highly correlated with full value property tax. Proportion of non-retail business acres per town. Oh, 1 minute. I mean, this is still very difficult to find, right? Can we label them? Let me just see. There was a variable. There was a variable which I could use. There is a property of heat map which can enable me to write the numbers there. So looking at the numbers, that will be good. But I can even look at the numbers over here, right? So Indus versus what did I say? Tax. Indus and tax. Where is Indus? This is tax. This is tax, and this is index. You see, 0.72. Right? It's quite high, quite highly positively correlated. And in the same way, if I look at this line only, minus 0.7, DIS is highly negatively correlated with Indus. What is DIS? Weighted distances to 5 Boston employment centers is inversely proportional or indirectly or negatively correlated to the proportion of non-retail businesses. Right? So these are the kind of relationships that we are able to find over here. These are the kind of things that we have to get rid of, unfortunately. We have to get rid of this kind of features. We have to get rid of either of these features because we cannot have a multicollinearity in the data. So let me just look at that parameter once. And in the meanwhile, can anybody tell me what we can do in this case? I mean, what shall we do to handle this kind of situation? If you remember what we did earlier.
VIF.
Okay. 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 What is VIF?
Variable inflation factor.
Yes. So that's one way. We can look at the factors Okay. Oh, sorry. We can look at the factor or features which are causing inflation in variance amongst others, and we can get rid of them. Yeah, that's one way. Any other methods? Any other ways? Any other ways at all? Yeah. Now this is good. This is now good. Any other ways, friends?
Feature reduction, variable
Yes.
reduction,
How? There's a specific
maybe
name to it. You are almost there.
dimension reduction. I mean, I'm just recollecting that
Okay. Yeah.
specific term.
It's closer
But
to dimensionality reduction. Yeah. That's a hint.
PCA, do you mean PCA?
No. PCA is good. I'm not saying it is not good. It is really good. We have not reached that stage. We have not looked into PCA. We don't know what is unsupervised learning or how to do PCA. But
Or
we have seen
discriminant
something.
analysis?
We have seen something earlier. We have seen something earlier when we looked into linear regression earlier. Anyone else who remembers? Your 70% answer was right there, Saransh. You will have to eliminate features. So feature elimination, these two words are there. But these two are the second and third words. What is the first word? Okay, the first word is recursive feature elimination. We use recursive feature elimination to find out which of the features are actually impacting the outcome, okay, in an order of the precedence. This is a functionality available in scikit-learn library already. We can use that and try to find out and try to order them uh, or order the features by comparing them with the target. So we need to join. We have to join these two data frames. We have not created a data frame of the targets, but let's just quickly look into this output first, and then maybe we are going to do that. So first of all, I see a negative value over here. Obviously, there is a negative relationship between indus and dis, and there is also negative relationship between nox and dis, negative relationship between age and dis. Okay, negative relation between age and dis. Let's try to find this. What is this? Weighted distances to 5 Boston employment center and age. These two are negatively proportional. Okay, negatively proportional. This is quite good information actually. You see how many questions you are answering without even asking the question. Nobody asked you to find out how is age and DIS features related, but we are answering that question. This is exactly what I said during the phases when we looked into requirement analysis, right? We will end up doing a lot of EDA, and that EDA will answer a lot of questions. So age, or the proportion of owner occupied units built prior to 1940, is inversely proportional or inversely affecting the weighted distance to 5 Boston employment centers. So cases where we have higher weighted distances to the employment center, or cases where or houses which are far away from Boston employment centers, right, have a lower age, right, have a lower age. The age being higher means you have a lower distance, right? That's how you can read it. It means the houses closer to the employment centers are built quite approximately near to the year 1940. Right, this is kind of an information which we can find out only by looking at this table, right? We can try to write these down and then we will be able to do a lot more, but let's try to see some kind of positive relationship. Why are we only looking at negatives? Tax, look at this, man, look at this. Tax versus RAD. What is RAD? Index of accessibility to radial highways. And tax, obviously this is absolutely obvious relationship is there. If there is a house which is closer to the highway, obviously the property tax is higher. This is something at least I have seen in the city where I live. Okay, I have seen this. The property taxes are higher to the societies or the apartments which are closer to the highways. especially the Mumbai-Pune highway. That I have seen. Yeah, that is correct. So quite good amount of information we are able to find out from this heat map, right? We are able to find out quite good information. So from here we can try to find out, or we can try to write down our findings as well. So I'll keep one section blank over here. Yeah, I can leave one section blank over here. I'll write my own findings and I will share the notebook. Maybe I'll request all of you to download the notebook from the system after I've uploaded it, right? Try to look into it. Try to put your findings over here, right? Try to put your findings here and let's see what we can do. So the next task, let's just write down what we are going to do next. So next task is going to be, we are going to findings from the correlation heat map of features, right? So this is one finding that we have to write down. This is TBD. I'm going to say to be done, yeah, or to be discussed. So I have to write this, and then here, let me just enter some. What is this one? Yeah. So this is good now. And here I'm going to say the next thing we need to do is that we would require creating the feature, the labels of the targets, the targets as a data frame, just like we performed with the features data set, right? And then combine the features and the targets. Why do we need to do that? So that we can use random sampling, otherwise known as train, test, split, right? Train, test, split, right? Or this is train, test, split method, I can say method, which I can use, okay, to create the training and testing data, right? That's one objective. And also to find the correlation, not causation, okay? A very, very important word, correlation, but not causation between each feature and the target. So we can plot some scatter plots, for example, right? And we can try to find out if there is any direct or indirect correlation between each and every feature and the target, right? But let's call it a day for now. I believe we have already consumed almost all of our time. So maybe we can call it a day and we are going to continue from this part. I would strongly recommend that I'll share this code as soon as the video recording is ready, right? Please go through the code. Please go through the findings. If you find they are wrong, please advise. Please try to change them. Please try to find more findings from this correlation matrix and try to write it over here, right? I'll also write my findings over here, right? And then from the next session onwards, we can continue accordingly, right? I hope that's fine with everyone. Then I'll stop the sharing. Let's call it a day for today. Thank you. Thank you, friends.
Thanks.
Thank you.
Good night.
Good
Good
night.
night. Good night.